Section 7.3.11, in an advertising campaign, a snack company claimed that every 18-ounce bag of its cookies contained at least 1,000 chocolate chips. Two statisticians attempted to verify the claim. The accompanying data represent the number of chips in an 18-ounce bag of the company's cookies based on their study. We're going to complete part A through E. We want to draw a normal probability plot to determine if the data could have come from a normal distribution. Now, in our previous exercise, we decided to find we used the observed values and the z-scores. Now, since we have so many data values, what we're going to do is we're going to use the QQ plot, but we're not going to be using the expected z-score. So let's open this data up in Statcrunch. So here's our data. We're going to open this up in Statcrunch. Okay, so what we want to do is we want to generate a QQ plot. So we're going to go to Graph and select QQ plot. We're going to select our column. And then down here, we want the normal quantiles to be on the y-axis. So we want to select that. And so we want to make sure that these observed values are going to be on the x-axis or the horizontal axis. So we're going to select Compute. And then I'm going to go ahead and copy this graph. And so this gives us somewhat of a normal distribution because it is close to, a lot of these points are close to that line. So therefore this does come from a normal distribution. Now what we want to do is we want to be able to determine the mean and the standard deviation of the sample data. So by doing so, we're going to come back here, we're going to select Stat, and then go to Summary Stats and select Columns. We got variable 1, and then we're going to want to find the mean and the standard deviation. And when we select Compute, then we get the following summary statistics. So we can see what the mean is. We're going to round that to 1 decimal place, and the standard deviation, we're going to round that to 1 decimal place as well. So therefore, here we have the following. We have the mean to be 1280.1, and we can see that the standard deviation is going to be 144.3. Okay, so now in part C, it says use the sample mean and the sample standard deviation obtained in part B as estimates for the population mean and the population standard deviation, respectively. We're going to draw a graph of the normal model for the distribution of chips in a bag of cookies. Okay, so we want to identify, so what we want to do is we want to be able to identify the values of U minus the standard deviation and mu plus the standard deviation. Okay, now recall that in our problem we know that our mean is 1280.1 and we know that our standard deviation is 144.3. Okay, so therefore we want to be able to find mu minus sigma, and so that is equal to 1280.1 minus 144.3, and that gives us a value of 1135.8. And then number 3, we're going to take the mean and then add the standard deviation. So it's going to be 1280.1 plus 144.3. When we add those together, we get 1424.4. So now let's draw our normal curve. So we have our normal curve. There's our bell curve. Okay, we know that our mean, mu, is equal to 1280.1, And then we have the two inflection points. We have an inflection point at 1135.8 because that's one standard deviation below. And then one standard deviation above gives us the other inflection point. And so therefore, this is the graph of the normal model for the distribution of the chips in a bag of cookies. Okay, next. It says using the normal model from part C, we want to find the probability that an 18-ounce bag of chips selected at random contains at least 1,000 chips. Okay, so reviewing the definition of at least. Okay, we know that at least means greater than or equal to. So what we want to be able to do is find the probability that X is going to be greater than or equal to 1,000. Okay, well, we also need to find the z-score. So we know that X is going to equal 1,000. Okay, we also know that our mean that we got from part B is 1280.1, and then we know our standard deviation is equal to 144.3. Okay, so now what we're going to do is we're going to draw our graph because we know that currently we have our mean located at 1280.1 and we have a value of 1,000. We want to find everything that's greater than that. Okay, so the next thing that we would do is we would want to find the z-score. So recall that z is equal to x minus mu over the standard deviation. And so that's equal to 1,000 minus 1280.1 divided by 144.3. And so the z-score becomes, rounded to two decimal places, negative 1.94. So therefore, in part 4, when now we draw the standard normal curve, that means now that our value of our mean is 0. And we now know that our z-score, instead of it being 1,000, is now negative 1.94. And again, the probability is that it's greater than. So we want to find the area to the right of that score. Okay? Okay, so what we want to do is we want to be able to find the probability of when z, okay, is greater than negative 1.94. Well, that's going to equal 1 minus the probability of z being less than negative 1.94, which means we need to find this area here, because we can find the area when we're using a table. So again, I'm going to show you all three, the table, the calculator, but first, let's go down and take a look at the z-score, negative 1.94. So we're going to take a look at negative 1.94. So we can see from there that is 0.0262. And that gives us an area of 0.9738. And so for this question, I believe MATLAB is going to want you to round it to 3 decimal places, which gives us 0.974. Okay, so now let's go ahead and quickly use the TI-84. How would we go about using the TI-84 calculator? Okay. So recall that the formula we have to use is normal CDF, where we have the lower bound, the upper bound, the mean, and the standard deviation. Well, since we're looking for the green area, the lower bound is going to be negative 1.94. So therefore, we're going to use normal CDF. The lower bound is negative 1.94. The upper bound is going to go to 9999. Okay, we know that our mean is 0 and our standard deviation is 1 because we're using the z-score. So let's go ahead and solve that on our calculator. Okay, so again, we're going to go here, second distribution, normal CDF. We got negative 1.94 as our lower bound. Our upper bound is 9999. Our mean is 0. Our standard deviation is 1. And then we get the following area. And as you can see there, if we round it to 3 decimal places, then we're going to get the same result over here, which is 0.974. Alright, so now let's take a look at Statcrunch. Okay, so if we want to use Statcrunch, we're going to go to Stat, we're going to go to Calculators, and then go to Normal. Okay, so in this scenario here, we want to find where it is greater than negative 1.94. So we're going to use the mean as 0. We know our standard deviation is 1. We're going to select the inequality that says greater than. And then we're going to put in negative 1.94, and that should give us the same area that we got in our calculator. So if we wanted to use Statcrunch, then that's another way of being able to get that result. Okay, so again, this is Statcrunch. So you can see here we get the same area here, and the same area here is what we got in step 4 down here. Okay, so what can we say? We can say that therefore the probability that an 18-ounce bag of chips selected at random contains at least 1,000 chips is 0.974. Okay, now we're going to move on to part E. So let's take a look at part E. It says, using the normal model from part C, find the probability that an 18-ounce bag of chips selected at random contains between 1,300 and 1,600 chips. Okay, so what we want to do is, again, we want to compute z-scores for 1,300 and 1,600. So first thing is first, if we look at our drawing, we know that we have a mean at 1280.1, and we want to find the area that's between 1,300 and 1,600. So here's 1,300, here's 1,600, and we want to find the area that's in between. So what we want to do is we want to find the probability that X is in between 1,300 and 1,600. So what we're going to have to do is we're going to have to convert them to z-scores. So for part A, we're going to look at 1,300, where X is 1,300. We know the value of the mean is 1280.1. And we know the standard deviation is 144.3. So, in order to find the z-score, we're going to call that z1. It's going to equal 1300 minus 1280.1 and divide that by 144.3, and that gives us a z-score of 0.14. Okay, and then for part B, we know that x is going to be 1600 using the same mean and standard deviation. So we have 1600 and we're subtracting 1280.1 divided by the standard deviation of 144.3, and that gives us a z-score of 2.2. Okay, so let's go ahead and move this down just a little bit here. Okay, so if we wanted to draw our new bell curve, just so that we can see this in terms of the standard normal curve, we now know that the mean is 0. And the two z-scores that we're looking for, we found to be 0.14 and then 2.22. Okay. So the first thing we want to do is, if we're using a table, we want to be able to find the area that's to the left of 0.14. So let's go ahead and do that. We want to find the probability of when z is less than 0.14. So let's go down here, 0.14. Okay, so we can see that we get an area of 0.5557. So that's equal to 0.5557. And so now we want to find the area to the left of 2.22. So we're looking for the entire area that's to the left of 2.22. So let's go ahead and find the probability of when z is less than 2.22. So we're looking at 2.22, so there's 2.2, and there is 2.2. So we can see that the area that's given there is 0.9868. Okay, so now in order for us to find the area here, we're going to take the area of the probability of z being less than 2.22 and subtract the area of the probability of z being less than 1.014. So then we can find the area that's in between here. So we're going to take 0.9868, and then we're going to subtract the 0.5557. And so when we subtract, we get the following area. We get 0.4311, which we can round to 3 decimals to be 0.431. So then we can come to the conclusion and state that therefore, the probability that an 18-ounce bag of chips selected at random contains between 1,300 and 1,600 chips, which is 0.431. Okay, and then let's just quickly do this by using the TI-84. Okay, so recall that we're going to use the following formula. Okay, so we want to find the area that's in between 0.14 and 2.22. So we're going to use normal CDF. The lower bound is going to be 0.14. The upper bound is 2.22 with a mean of 0 and a standard deviation of 1. So let's just go ahead and put that in our calculator just to review. So second distribution, go to normal CDF. We know our lower bound is 0.14. Our upper bound is 2.22 with a mean of 0, standard deviation of 1. And so therefore there we get the same area that we got from our problem. And so then you would round accordingly like we did earlier. And then if we wanted to use Statcrunch, then we're going to go ahead and open up our Statcrunch. Let's go to calculators. We're going to go to normal. Okay, so we know our standard mean is 1 and standard deviation is 1. And we want to find that it's in between these two values. So we're going to select up here between. And so we know that the lower bound number is 0.14. We know that the upper bound number is 2.22. And then we're going to select compute, and then you can see the area is 0.4311. So using Statcrunch, you can go that route as well. And so therefore that is the conclusion of this problem.